Welcome to another episode of Terry's Notes, and today we are going to be looking at rusting. Now, what is rusting? Now, corrosion occurs on the surface of a metal. As a metal corrodes, it initially forms oxides of the metal. Rusting is a special form of corrosion and applies to iron and its alloys. So once we use the word rusting, we are referring to iron. Oxygen and water are required for iron to rust, and rust is hydrated iron trioxide. So sometimes we see rust being written as Fe2O3.XH2O. Rusting is an electrochemical process. The rust that forms on an iron surface does not adhere to the surface. It flakes off, exposing the fresh iron surface to more corrosion. Okay? So this is an important point here. When the oxide forms on iron, it flakes off, it doesn't stick to the surface, and it exposes fresh iron for more corrosion to take place. The rusting process. Initially, iron atoms lose electrons to form two ions, and this is expressed as by this equation here. At the same time, oxygen and water molecules react to form the hydroxide ion. So we have the hydroxide ion being produced here. The aqueous iron 2 ions then react with the aqueous hydroxide ion to form solid iron 2 hydroxide. So you have this reacting with this to form the iron 2 hydroxide. And finally, iron 2 hydroxide is oxidized to form a hydrated form of iron trioxide, which is rust. How do we prevent rusting? We can basically use oiling, greasing, and painting the iron surface. This prevents water and oxygen from coming into contact with the metal surface. We can also coat the iron surface with a layer of zinc. This process is called galvanizing. Zinc forms an adherent oxide layer. If the metal surface is scratched, the zinc corrodes in preference to the iron because it is higher up in the electrochemical series than iron. Right? We also can coat the iron with a layer of tin, like in tin cans. However, when scratched, the iron rusts more quickly than the tin because iron is higher up in the electrochemical series than tin. So which is different to when we different from the process of galvanizing where we use zinc, in which case zinc forms an adherent layer, and if we scratch the metal surface, the zinc corrodes in preference to the iron. The next thing we can do is attach a sacrificial anode like magnesium. The iron object is attached to a piece of magnesium. The magnesium corrodes in preference to the iron because it is higher up in the electrochemical series than iron. So you need to be familiar with the various methods of preventing rusting. Now, if we look at the corrosion of iron now, we have a different story here. If a clean piece of aluminium is exposed to the atmosphere, a layer of aluminium oxide forms, that is Al2O3. This oxide layer adheres to the surface, and this prevents further corrosion from taking place. Right? In the case of iron, when the oxide is formed, it doesn't stick to the surface. It flakes off and exposes more iron. In this case, when aluminium is exposed to air, it forms an oxide layer which sticks to the surface. And the thickness of this oxide layer can be increased by an electrolysis process called anodizing. Okay, an alloy is a mixture of two or more metals. Now, why are alloys used instead of the pure metals? The physical properties of the alloy is different from the physical properties of the pure metal. So, in the case of the alloy, it may be harder, it may have a lower melting point, or it may be resistant to corrosion. Now, let's look at an alloy of aluminium. Example, duralumin. The composition. Now, you need to be able to give some examples of alloys. So you can just choose a few and try to remember the composition, the use, and the property. So duralumin, it's 95% aluminium, 4% copper, and we have traces of magnesium and manganese. And we use this alloy to build aircrafts. And the properties are, it is lighter than aluminium, is light as aluminium, but it is stronger than aluminium. right? An alloy of iron, steel. Steel is an alloy of iron, and the composition of steel is iron and carbon. And what do we use steel for? We use it to make cars, buildings, machines. And what are the properties? It is harder and stronger than iron, right? Another alloy, we need to look at alloys of lead. So an alloy of lead is solder, and the composition is tin and lead. And what do we use it for? We use it to join metals, or we use it to join pipes. And the property, or the main property we use in this case here, is that it has a lower melting point than either the lead or the tin.